Okay, here we go. Dot product. Dot product, dot product, dot product. So you learned how to add vectors. It was no big deal. You learn how to subtract vectors. It was no big deal. But multiplying vectors, slightly different. Okay? So here's what you do. Suppose you have a vector. We'll call it vector AB. And we're multiplied by vector CD. And most of the time you just assume that you would take A times C and then B times D and you get two parts to it. That's not quite the way it works. It's A times C plus B times D. You actually get one numerical value. One numerical value. That's the dot product. So it says find the product of the vectors and the angle between them. We'll talk about the angle in a second, but right now let's take vector U times vector V. So we do negative 1, 2, and we multiply it by 2, 3. So we take negative 1 times 2. Now I've learned over the years people have gotten confused by this. Watch as we do this. It's not negative 1 times 2. It's negative 1 times 2. See that? So I'm just saying that's people that make that mistake on the test are like, well, I just thought you multiplied these and these. No. So I should really switch one of those two, shouldn't I? Yep. Negative 1 times 2, that's going to be negative 2. And then 2 times 3 is 6. And so we get 4. So that's their product. That's it. Okay. This is, you have a vector I minus j, which is just another way of saying 1, negative 1. And then 3i plus 4j, which is another way of saying 3, 4. So let's multiply those together. Okay. So I'm going to take 1, negative 1, and I'm going to multiply it by 3, 4. How do I do such a thing? Yep, 1 times 3 is 3. And negative 1 times 4 is negative 4, and I get negative 1. A little bit more complicated now. Now we want the angle between the two vectors. So, for example, if I were to draw this vector right here, negative 1, 2. So negative 1, 2 would be back 1 and up 2. You know, that would be that first vector. And the other vector 2, 3, so over 2 and up 3. Somebody describe for me the angle formed between those two vectors. Describe it. Say something about it. Bigger than? Think it's bigger than 90? Looks pretty close to me. Yeah, it looks close to 90. I would say it's definitely bigger than I would say like 40 degrees. Wouldn't you agree? Definitely less than 180. Right? I want to find that angle right there. The way we find an angle between two vectors is we say that the cosine of the angle is equal to the dot product, which is u times v. So we multiply those two together. But then we divide it by the magnitude of u times the magnitude of v. So it says find the product of the vectors and the angle between them. True or false, we've already found the product. So when we set this up, it's really not that bad at all. We set cosine of theta is equal to, the product is already 4. We've already determined that. Divided by, and now we need the magnitude of u and the magnitude of v. Do you remember how we determine the magnitude of a vector? Square root of a squared plus b squared. So let's see, this isn't too bad here. If I were to square root a squared plus b squared, what is a squared plus b squared here? It's going to be 1 plus 4, which is 5, so I'll have the square root of 5. times the square root of, okay, now I got 2, 3. What's going to be the magnitude of 2, 3? 13. Everybody got 13? So I know that the cosine of this angle is equal to 4 divided by the square root of 65. Agreed? So if I know that the cosine of the angle is equal to 4 divided by the square root of 65, then I can find that by going second cosine 4 divided by square root of 65. And I'm going to make sure that I'm working in degrees, which I am. I hit enter, and I get 60.25 degrees. That's the angle formed between the two vectors. I'll draw the next one as well, just so we can make sure we get a good view of it. Over 3, up 4. And then over 1 and down 1. What do you think? Think greater than 90, less than 90? Any thoughts? Looks a little bit bigger than 90, maybe? So we set this up by saying the cosine of theta is equal to, what goes on top? -1, because that's the product. The dot product goes on top. And then the bottom, we just have the two magnitudes multiplied together. So the magnitude of this will be, hi! 1 squared and -1 squared. 1 and 1 makes 2. So we got square root of 2. And then, see, 3 squared is 9. 4 squared is 16. 25, so 5, yeah. So we could go like, you know, like 5 roots of 2, something like that. I think that the mistake that people make on this part on the test is when they go cosine inverse, -1 divided by. Make sure you put parentheses around there if you're multiplying two things together. So it's parentheses 5 roots of 2. And we get 98.13 degrees. So Morgan was correct, which shouldn't surprise anybody. Pretty much always right, Morgan? Yeah. Yeah. No, she said it was probably just a little bit more than 98 degrees. I just like to try to, or a little bit more than 90 degrees. I just like to try to verify my answer a little bit. Sketching the graph at least tells, like if I would come up with 13 degrees, I would have really wondered, you know what I mean? Like, why, you know, maybe I should make a different drawing. Maybe I'm a bad artist, who knows? So yeah, not too bad, huh? I mean, it doesn't really get much more difficult than that at all. I think that's the most challenging part for people is finding that angle. We're just going to classify a couple terms. Orthogonal vectors are vectors that form a 90-degree angle. And there's this really cool way we can see if vectors form a 90-degree angle right away. And I want to just try to help you guys understand this. Okay, so 90 degrees is right up here, right? What's that terminal point? What's that coordinate? 0, 1. Is cosine the x value or the y value? X. So that means that 90 degrees happens when cosine of an angle is equal to 0, right? And so if we have u times v divided by magnitude of u times magnitude of v is equal to 0, and you were to cross multiply, look, that gives you 0, and that gives you u times v. So it just turns out that if you do a dot product and you get 0, it means they're 90 degrees. So it's kind of a really cool way to see if, you know, they're like perpendicular to each other, stuff like that. So like this one, it says determine whether the following vectors are orthogonal or they form right angle. So when you look at these, you don't have to work to find the angle between them so much. You just multiply them. If you get 0, they're orthogonal. If you don't get 0, then they're not. So let's multiply them. We got 2, 1 times -1, 2. And what do you get? Negative 2 plus 2, which is 0. So, yes, they are orthogonal. You guys remember from geometry talking about the orthocenter and the circumcenter and those things? A little bit? No? You suppressed it. Thank you. The next one we would take, so this is written in terms of I and J, which I won't do to you on the test. I'm going to start getting rid of that from the notes. It just doesn't seem very applicable, but it's just 5 negative 3 times negative 6, 10. What do you think? No? But don't you get negative 30 and 30? Get negative 30 and negative 30. Yeah, so it makes negative 60. So no, they are not orthogonal. Oh, yes, thank you. Nope. I mean, the fact is that you see that some people would have made that mistake, right? I kind of tried to trick you. Okay, and we'll skip example 4, and we're going to move towards this piece right here. Yep. And I think that this should be it. Let me just check this piece here.
They're not word problems, are they?
Yeah. So normally we would spend one extra day doing word problems, and a lot of people ask about the applicability of the mathematics. And I'm going to pause the video right now just to talk to you a little bit. We're going to first define work, and work is equal to your force times your distance. Okay? Work is equal to your force times your distance. It very much is. I mean, this would be an application into a physics piece. Okay? So find the work done by the force F in moving the object from P to Q. So all I need is a force vector, and the force vector is I plus J, or 1, 1. And now I need a distance vector. It says I'm moving the object from P to Q. From P to Q. Tell me, if I move it from P to Q, how many units do I move it horizontally? 3. How many units did I move it vertically? 4. And so the amount of work done is 1 times 3, which is 3, plus 1 times 4, which is 4, or 7 units of work. No big deal, right? What is my force vector going to be for this one? 3, negative 2. And my distance vector may look a little bit more complicated. In the end, just take the second x value and subtract the first x value. Negative 1 minus 0 is negative 1. It's moved negative 1 units horizontally. And then 2 minus 3 is, it's moved negative 1 units vertically. So 3 times negative 1 is negative 3. And negative 2 times negative 1 is 2. So negative 1 units of work have been accomplished. Meaning you're worse off than when you started. Right? You're Superman. You're trying to catch the falling building, and it's collapsing on you. Negative 1 units of work. Yeah, I know. All right, so let's do the last problem and be done with this unit. A lawnmower is being pushed a distance of 80 feet at a constant force of 60 pounds. The handle is at a 35-degree angle to the ground. Find the work being done. Anybody mow the lawn? We got 1, 2, 3, 4, 5. Got about 5. You're not allowed to? Have you hit things, Morgan? your mom loves mowing the lawn. She doesn't want anybody else to do it. Got it. Okay. That makes sense. Okay, Esther mows your lawn. What? What?
She likes like if I don't want to do it, like I'll be like Esther.
No, no, you did not just say that. Okay.
She likes mowing the lawn.
That sounds absurd. All right.
I know.
Okay, so here's Esther. We'll go Esther. She likes to mow the lawn. She's got a lawnmower. It's like smoke coming out of the engine. It's burning a little bit of oil and stuff. You don't have it's totally optional. Drying is optional. I'm kind of gifted at it, so I'd like to do it. And this is the grass that she's mowed over, and this is the grass that she needs to mow yet. Put a tree there, some leaves, and yeah, there we go. Mrs. Huebner would be very proud of me. Okay, so we're wondering the work. Work is equal to force times distance. Let's do the easy part first. The first thing we need is we need the distance vector. Can you tell me how far are we pushing it horizontally? 80. And how far are we pushing it vertically? None. Is everybody clear with the distance vector? That was really easy, wasn't it? Yep. Yep. Think of like X and Y. We good?
Yeah.
All right, so it says that this handle forms a 35-degree angle with the ground. And we are pushing on it with a force of 60 pounds. So this the magnitude of this vector is going to be 60. The handle represents the magnitude of the vector. And 60 would be, here's the video, 60. Okay. So 60 is what we're, yeah, that's our force. But we would like to have, for the force, we would like to have both vertical and horizontal components to the vector. So one of the last things we did the other day is we came up with horizontal and vertical components of the vector. Now I'm going to do it one more time. I'm going to call this B. I'm going to call this A. But can somebody think of a trigonometric function that deals with both A, 35, and the hypotenuse? Cosine. And we said that A was equal to the magnitude of the vector times the cosine of theta. And that B was equal to the magnitude of the vector times the sine of theta. So if you want to come up with the horizontal and vertical components of the vector, simply just take the magnitude and multiply it by sine or cosine of the angle. Is that okay? Think of sine as cosine as horizontal and sine as vertical. We all good there? So let's do that. So we have A is equal to 60 times the cosine of 35 degrees. And B is equal to 60 times the sine of 35 degrees. And that will give us our force vector. So we turn on our calculator, and we take 60 times the cosine of 35, and we get 49.15. And then we take 60 times the sine of 35, and we get 34.41. So what do you notice is going to happen as I multiply these? One of them is going to be 0, right? There's no work being accomplished vertically, is there? Because are we somewhat pressing vertically? Somewhat, but the lawnmower is not going down into the ground. So If you take 49.15 times 80, 49.15 times 80, we get 3,932. And we add that to 0, and we get 3,932. And how do we measure it? We measure it as against force times distance. So distance is in feet, so feet, and then the multiplication sign, pounds, foot-pounds. That's our work, foot-pounds. I would just like to add one last piece here so that you can understand. Suppose that instead of Esther, suppose that this is me. This is Kevin. Okay, and Kevin weighs, let's say, 180 pounds. If there was a scale here, okay, if there was a scale here, and you're pressing, or let's not say that I weigh 180 pounds. Let's say that this lawnmower weighs 100 pounds. Well, as I press on it, it would now feel like it would weigh 134.41 pounds as we press down, right? So figuring out the horizontal and vertical components, they do have meaning and values moving forward. So anyway, all right, there we go. So that's it. Goodbye.